Hello and welcome to today's class. We are going to look into new topic, indices and logarithms. To start us off, we're going to start with indices. So basically, indices is plural for the word index. All right, indices is plural for the word index. And index in this particular case scenario also means power. All right, power. So for example, let's say you're given a number raised to a number. All right, let's say you're given a number 2 and it is raised to 2. All right, this is commonly known as 2 squared. All right, so basically this superscript here is what we are calling the index. It is the number in which the base is raised to. All right, so we can also talk, let's say, of a number, let's say 3 raised to 5. Okay, so basically this number that we know as power, all right, the number that has been raised to a certain power. So the power is what we call index. All right, and so if there are many, then we call them indices. So in this particular class, we're going to focus on laws of indices. We're going to focus on laws of indices. What are some of the laws that you should look at whenever you're dealing with indices? All right, what are some of the laws that you should always be looking at whenever you're dealing with indices? And they are 3 laws. So the first law, what we call the sum rule. All right, the first law, what we call the sum rule, it requires that whenever you have numbers of the same base, okay, so we have a times a, and a in this particular case is raised to n. All right, and a in this particular case is raised to m. All right, so whenever you are having numbers of the same base, the keyword there is same base. Okay, whenever you're having numbers of the same base and they are being multiplied together, it is always going to be the same as taking a into adding the powers. Okay, so you add n plus m, you add n plus m. So this here is what we call the sum rule, the fact that we are adding the powers. Okay, so whenever you are having numbers of the same base, all right, and you are multiplying them to each other with each other, of course, and they're raised to different indices, then we say that you add the powers to get the final product in that particular scenario. Then the second rule is what we call the difference rule. The second rule is what we call the difference rule. So the same rule again, whenever you have numbers of the same base, in this particular case I'm having a, all right, raised to n again, and I am dividing it with a raised to m. All right, so the numbers have to be of the same base, common base. All right, so this one also can always be the same as taking a and n minus m. All right, so you subtract the powers, n minus m. So this is what we call the difference rule. So that should stick whenever you are having same base, of course, and you're dividing them and they're raised to different indices, then it's always going to be the same as taking the difference of the power. And finally, we have what we call the product rule. All right, we have what we call the product rule. So basically, product rule requires that whenever you are having, let's say, a number a and it is raised to n, and now you are trying to raise it to another number m. All right, so it is a raised to n and you're trying to raise it to another number m. It is always going to be the same as taking a and the product of the powers, n times m. All right, the product of the powers, that is n times m. So these are the 3 laws of indices: the sum rule, the difference rule, and the product rule. Let us look at some examples where these laws are actually put in use so that we understand how to actually apply them in real problems. All right, let's go ahead and solve these particular problems. So we've been told to evaluate A, B, and C. So A, we're having 2 raised to 6 times 2 raised to 4. All right. One thing I want you to note is that all of them have common base, and the common base is 2. All right. And so because they have common base, we are going to apply what we call the sum rule. Why? Because we are multiplying these two numbers there. So right now, I want you to recall the sum rule. Sum rule basically states that if we are having common bases and we are multiplying them, then it's the same as having the sum of the power. So this is going to be the same as having 2 into 6 plus 4. And so basically the answer is going to be 2 raised to 10. All right, very simple. All right, that is the first law of indices serving us right there. Then the second law of indices helps us solve part B. All right, so one thing you want to check is, first of all, do they have same base? Yes, they have common base. This here is 3, this here is 3, all right? It is 3 raised to a number, all right? So they have common base. And so what do we know about dividing indices with common bases, all right? So what we know is we are going to apply the difference rule, which simply states that we're going to then have to take the difference of the powers. So it's going to be 3 raised to 10 minus 4. So this here is going to give us 3 raised to 6. And that there is going to be our answer for that particular problem. Now, for the last problem, we are having 5 squared raised to 3. All right, we are going to apply the product rule. All right, as we are having power raised to another power. All right, so basically the third rule, product rule, requires us that whenever we have a situation like this where we have an index already, all right, an index being raised to another index, we just multiply them. So basically this is going to be the same as having 5 into 2 times 3, which is going to give us 5 raised to 6. And that there is going to be the solution for that particular problem. Let us solve the last set of problems under this, then we call it a day. I hope by now you are already seeing this in action and getting to understand it even better. All right, so for our last example, we are having a situation where, of course, we have to apply the knowledge of indices to find values of unknowns. So in the first problem, we are having 2 raised to x, all right? Then the whole index has been raised to 3, and that should be equal to 2 raised to 12, all right? That should be equal to 2 raised to 12. So basically, we are going to look at the powers, the indices, all right? And just focus on that. So what we know about this here is we are going to apply product rule. This basically requires us to multiply x by 3. And so when we multiply x by 3, we are going to get 3x. And that 3x should be equal to 12, as you can already see from this particular problem. Okay, 3 times x should give us 12. And so for us to find the value of 12, we're going to divide the left hand side and the right hand side by 3. And so that's going to leave us with x being equal to 4. Now that is already solved, and we've used our knowledge on product rule to actually go ahead and solve for that. Now for the second problem, we are having 4 cubed raised to x equals to 64. Now before you solve this problem, you want to first of all make sure that 64 is written as a power of 4. You want to make sure that 64 is written as a power of 4. So that's going to basically give us 4 raised to 3 into x equal to 4 raised. So what number do we have to raise 4 to get 64 is the question you want to ask yourself. All right, so you can use your calculator to find that out, or whatever you have available to you. So for us to get 64, we have to raise 4 to 3. Okay, so basically 4 raised to 3 will give us 64. Now that we have our bases looking the way we want them to be, they are all common, they are all made of 4. So we are going to use the power rule to then solve the value of x in this particular problem. And so it's going to we're going to have to multiply 3 by x, and that's going to be 3x being equal to 3. So for us to find the value of x, we're going to divide the left and the right hand side by 3, and so you will notice that the value of x will actually be 1. So that is it for this particular class on the laws of indices. There are 3: sum rule, difference rule, and product rule. I hope that you are able to pick it up as you should, and if you haven't, drop a question in the comment section, and if you have, do more examples related to these particular laws. See you in the next class, and have a wonderful day.